critical ratio is a formula, time remaining divided by work remaining. Critical ratio is also a signal. When you fill out that formula, it is signaling something. This particular problem here is not actually asking us to calculate the critical ratio, fill out the formula. It's asking about the signal. Let's take a look. Suppose you have 3 jobs waiting to be completed, and you must determine the sequence in which these jobs should be worked on. You've calculated the critical ratio for each of these jobs, and the result is that, now see, notice the work's already done. Job A has a critical ratio of 1.27, Job B has a critical ratio of a negative 0.89, and Job C has a critical ratio of 0.15. So, while critical ratio is a formula, time remaining divided by work remaining. You don't have to fill out that formula for this particular problem. It's already been done for you for these 3 jobs. Now, what is it that we do have to do? Well, notice what the question is. Which of these jobs is already late? Right. What is the signal for already late? In the context of critical ratio. Oh, well, if critical ratio is time remaining to work remaining can't turn out to be a late or negative number. Only time remaining could. Yes, if the critical ratio is, let me think, less than 0, negative, we know that we're late. That's the signal. If you calculate the critical ratio for a particular job and that number comes out negative, then you know that that job is late. The reason it would come out negative has to do with the time remaining. How do we calculate time remaining? Time remaining, well, there's the due date when we promised it, and then you subtract out, well, where are we right now, in order to reveal how much time's remaining, how much time do we have. When that number goes negative, that means that right now is already after the due date, right? You're already late. Oh, so actually to answer this question, the only thing that you need to do is just look for which jobs have a negative critical ratio. Of which, okay, A, 1.27, nope. B, negative 0.89, job B. Let me check C. C, critical ratio of, no, it's not negative. Okay, so negative critical ratio means late. The next question is about the same 3 jobs, if you look. Okay, 3 jobs waiting, you've calculated critical ratio, 1.27, negative 0.89, and 0.15. Okay, this is the same 3 jobs. The question's different though. It's asking about a different signal. Which of these jobs is not late at this moment but will be late? All right, we had just commented that the signal for already late is negative. The signal for not late, at the moment we're looking at the report, but will be, is the critical ratio is positive because it's not late, right? It is a positive number, but less than 1. That's the key. Why, now you say, why? Oh, because it's time remaining. How much time is left before the deadline to work remaining? That is the critical ratio. So, if the work remaining is larger than the time remaining, this ratio comes out to a fraction. The denominator is larger than the numerator, and that is exactly a situation in which you have more work than you can do in the time that's left before this whole thing is late. And that is a situation in which, as you're looking at the critical ratio, it's not late at the moment, the due date hasn't passed, but there's no way we're going to make that due date. It's going to be late. So anyway, to answer the question, we're just looking which one of them fits that description. Has a positive critical ratio, but it's less than 1. A, 1.27, nope, that's not the case. We already knew that B is late because it's negative. Right, but job C, see how that's a a fraction. Job C has a positive critical ratio that's less than 1. Job C is not late at this moment, but job C is going to be late.